Hi everyone, this is the help video for Unit 2 Test 2.04, all about expressions. And we covered the following standards: comparing and simplifying expressions to determine if they're equivalent, laws of exponents, combining like terms, and multi-step order to simplify expressions. So please make sure to use this help video when completing the test, and also have your notes open as well. So again, this is the 2.04 unit test on expressions. Let's go over the first question, which is all about using order of operations. And when we use order of operations, we do have a common acronym, PEMDAS, or sometimes GEMDAS. So the first step in any order of operations is any grouping symbol. That could be absolute value bars, brackets, fraction bars, parentheses, any of that. So when we're looking at our question, we do automatically see an absolute value bar. The absolute value of a negative number is always a positive number. So I can just go ahead and rewrite that, and I can keep going. And it's really important to keep organized when doing this, and not to try to do everything in one step. Rewriting every single line will help keep the question organized. So we've used the first one. The next one in line in our order of operations is exponents, and we do have an exponent here. We have 3 to the power of 2, and just to solve that over here, 3 to the power of 2 is equivalent to 3 times 3, which is equivalent to 9. So I can again rewrite all of these and include the new step that I just worked out, which is 9. So I've used my exponents. Next in my list is multiplication or division. I do have multiplication here with this 2 times 4. 2 times 4 is 8, so I can rewrite this as 8 instead of 2 times 4. And finally, I have only addition left. So 5 plus 8 plus 9 equals 22. So again, when doing order of operations, very important just to follow every step in sequential order, making sure that we start with anything inside parentheses or absolute value bars, then exponents, then any multiplication division, then any addition subtraction. For question number 2, we need to factor. So they're looking for an equivalent expression or another way that this term can be written. Now, when finding equivalent expressions or when factoring, we want to find a term that both of these terms have in common. So we can divide both of these terms evenly by 3. So watch what happens when I divide 15g divided by 3. Well, I know that 15 divided by 3 is 5. So I can apply that logic to 15g divided by 3, 5g. And I'm putting it over here because you'll see that there is a 3 on the outside of parentheses. So this indicates that I have pulled that 3 out via division, and I'm only putting what's left inside the parentheses. My next term is negative 21 divided by 3. Negative 21 divided by 3 is negative 7. And this would be my final answer. So again, with factoring, find a number that both terms have in common, divide out. Whatever number was divided out, put on the outside of the parentheses, and whatever is remaining, put on the inside of those parentheses. A common mistake that people make is they'll remember to do the first part, but then they completely forget to do the second term. Please, please remember to factor both of your terms. You should be dividing by a number that both terms have in common. Our next question is a word problem. Each week, Sam earns X dollars by walking the dogs. At the end of 1 month, he earned another $30 delivering pizza. Sam writes the following expression to determine his income for the month: 30 plus X plus X plus X plus X plus X. What is another way? So again, we're looking for an equivalent expression that Sam can write this expression to determine how much he will work. So it's important here to look for like terms. Again, like terms are anything that have the same variable or exponent combination. In this situation, we do have these 4 x's. So I can rewrite this as, instead of x plus x plus x plus x plus x, I can rewrite that as 4x And this would be my final expression. This is equivalent to this one, but again, it answers the question. They're asking for another way for it to be written, and I can do that by combining like terms. For question 4, we're going to use the quotient power for exponents. The quotient power states that if you have two powers, which we do here, with the same base, so we have 5 to the power of 22 and 5 to the power of 4, and they are being divided. Again, we can see that here with the fraction bar. A fraction is division. Then we can subtract our exponents in order to simplify. So 5 to the power of 22 minus 4 is the same thing as 5 to the power of 18. So we talked about this a lot in live class. Remember, when you're doing this, use that common sense. If we have, like in this situation, two powers being divided by each other, that's something that gets smaller. So similarly with our exponents, they would also get smaller by using subtraction. So for quotient law of exponents, when two powers with the same base are divided, the exponents are subtracted. Question 5 is all about combining like terms. So again, when combining like terms, I'm looking for the same variable and exponent combination. And I'm going to go ahead and color code here, and remember to bring my sign with me. Very important when rewriting. So first I have these terms that just have an x. 2.5x minus 0.4x. You'll notice again, I brought that negative sign with me. This can simplify to 2.1x. Now I'm going to look to see if I have anything else. I have positive 7y, but there are no like terms, so I can just bring that down. And then I also have this negative 3. Again, there are no like terms that I can combine with that negative 3, so this would be my final answer. Again, I am taking my sign with me when I underline or highlight. Very important to take that leading sign. It will change the answer. Question number 6 is also combining like terms, and you'll notice the way that the question asks it, it's find an equivalent expression. So an equivalent expression is something that equals, but may look a little bit different because the numbers have been mixed up or they've been simplified. So again, I'm looking for things that have the same exponent and variable combination. Right off the bat, I see that I have these x cubed. I'm taking my sign with me, 5x cubed minus 2x cubed. Then I can move on to another set. I have x, I'm taking my sign with me, a positive x plus 5x. And then my last one, just my constant numbers that have no variables, negative 3. Ooh, I thought my color changed. Let's fix that. Negative 3 and negative 1. So negative 3 minus 1. Now I can go ahead and solve the things that are the same color. 5x cubed minus 2x cubed. I just work on those leading numbers. 5 minus 2 is 3, so 3x cubed. Next, my greens, I have a positive x plus 5x. That is 6x. And finally, for the yellow, I have negative 3 minus 1, which simplifies to negative 4. So again, finding an equivalent expression means combining those like terms. I found the things that have the same exponent and variable combination. I highlight or underline the leading sign. So the sign that's in front of that number, very important to include. And then I go ahead and simplify. Question 7 is all about using the distributive property. The distributive property is the opposite of factoring. So if you remember back to question 2, factoring was dividing out of both terms. Distributive property is multiplying in. So anytime you have a number that is next to parentheses like that, that indicates to us that we are multiplying. A common mistake is that people do not distribute to both terms. We have two terms here. So we're going to multiply by both. First, we have 2 times 1 over 4x. And then we also have 2 times negative 1/3. And we can go ahead and multiply. This simplifies to 2 over 4x minus 2 over 3. And we could simplify this down further to 1/2 x by just simplifying this fraction, minus 2/3. Again, the important part to remember here is when using the distributive property, you are distributing that number on the outside to both of the terms on the inside by multiplying. And you'll see both of these terms were multiplied. So this would be your final answer. Question number 8, adding linear expressions. The wonderful thing about adding linear expressions is it's the same thing as combining like terms. So I have a linear expression that's being added to a linear expression. I can drop those parentheses and combine like terms as normal. So I'm going to go ahead and do that. And then I can start to color code and coordinate my like terms. So for like terms, I have 2 items that have an x, or 2 terms that have an x. And then I have those 2 terms that are just constants. So I can rewrite this. I have 1 over 3x plus 1 over 4x. Now I can combine those, but I do need to do a little bit of work because my denominators are not the same. So I'll do that in a second. And then I have negative 11 plus 10. Let's look for a second and remind ourselves how to combine fractions that have different denominators. So I'm going to bring this work over here just so I have room. Over here, I have 1/3 plus 1/4. My denominators are different. So I need to find a number that I can multiply to get both of these to have the same denominator. I'm going to give these a denominator of 12. And I picked that simply because I'm just going to multiply the fractions by the opposite denominator. So I can multiply this fraction by 4 and this one by 3. That's going to give me 4 over 12x plus 3 over 12x. So again, I multiplied this fraction by 4 over 4. I multiplied this fraction by 3 over 3. And now I have common denominators and I can combine these. 4 over 12x plus 3 over 12x is 7 over 12x. So now I have simplified my 2x terms. And then I have my constant terms, negative 11 plus 10 is negative 1. So this would be my final answer. Again, when adding linear expressions, drop the parentheses, combine like terms. In this situation, I had fractions, so I needed to find common denominators to simplify. Question 9, in this instance, we are subtracting like terms. So subtracting is similar to adding, except there's a subtraction sign. So what do we need to do with that? We need to, I'm going to use that word again, distribute that negative sign to both terms inside our second set. And we can rewrite this. 4y minus 10, you'll notice that the first expression remains untouched. But now this negative sign is going to apply to both terms. This 2y is now going to become a negative 2y. And this positive 3 is now going to become a negative 3. Now that negative sign has distributed, now I can color code and solve. 4y minus 2y, and then I have my constants. I have negative 10, and I have negative 3. I can simplify. 4y minus 2y, 2y, -10 minus 3, -13. And this would be my final answer. I cannot combine these any further because I have no more like terms. So again, with subtracting linear expressions, you take that negative sign and you apply it to both terms inside the parentheses to change the sign, then you can combine like terms. Last question is question number 10, and this we're using the product rule of exponents, another law of exponent that we reviewed in this unit. The product rule states that if you have the same base, which we do, we have a base of 1/3, and it is being multiplied, which it is, then we can add our exponents. So this is the opposite from the quotient rule, which we discussed earlier. The quotient rule, when you're dividing, you subtract your exponents. In this case, we're multiplying our bases, so we add our exponents. This leaves me with an exponent of 2 plus 7, which can simplify down to 9. So my final answer here would be 1/3 to the power of 9. So that is the end of our review for Unit 2. There are 11 questions. One is a bonus question. Make sure that all assignments in Unit 2 are caught up. Remember that you will get one attempt at first on the test, and then it will be reopened for more attempts once you can practice with your teacher. If you need anything or if you have any questions, feel free to reach out. But remember, use this video, use your notes when taking the test. Have a great day.